Hello friends, I'm back with another video, and this time this is about database 101. So we will understand what is the database, how it is accessed, what are schemas, primary key and foreign key normalization in this video. And let me start with giving you a scenario. So whenever you access your mobile banking application, or maybe your GPay or PhonePay, from where we normally nowadays check our balances, what happens is that you as a customer, let's say, are using some kind of a mobile device, okay, and you check the balance, right? You check balance. What happens is that you basically connect to some system at the back end, maybe what we have understood till date, that's a front end back end architecture or a client server architecture, where this is the client and there are some servers over here, and those servers can be some app server and not app server. We'll start with something called as web, then app, then database. So you must be a thought comes to our mind that why it happens is that every time you check your balance, you get the exact correct balance all the time. I mean, for example, if you do some transaction right now, let's say you have a balance, currently you have a balance of 10,000 and you transferred 2,000 to someone, and immediately after doing the transfer you check your balance, you can actually see 8,000. Okay, you can actually see 8,000. Now how this happens is that it means that your data, your entry of this 8,000 or your previous entry of this 10,000 is stored somewhere. That somewhere is called as a database. So whenever you do a balance check, whenever you do in fact a transaction, how it happens that this process which I explained over here, 10,000 minus 2,000, that happens in the database where the previous amount was 10,000 and 2,000 was sent to someone else, and then the remaining balance was 8,000. Okay, so now this is an example which I gave you, okay, just to understand or just to relate what is a database. So database is a central, I should say, a kind of a repository or something like a persistent memory, I should say. So it is not something like a server where you have a RAM, right? You have a RAM or memory which is temporary, where you just restart the server and everything is just gone, right? It is not like that. It is something which is persistent. So many people in the industry, in the IT industry, also refer to databases as persistence or persistence layer. Just keep that in mind. Okay, so moving on to the next thing. So how does this database look ideally? Let's take a look at that. Normally what happens is that you can imagine database is nothing like a table, or maybe a spreadsheet, how you see in Excel, right? So for example, I just mentioned that you have a account, okay, or you are checking the balance. So hypothetically, if we take an example, there is a account table, okay, in which you have certain rows and columns, simple like Excel, as I mentioned. For example, you may have a column as account number, then you may have a column, let's say, customer ID. This ID is very important. In a moment I'll explain you why. And maybe you have a column, let's say, balance. So you can have a 001, then maybe C001 is the customer ID, and then you have a balance of 10,000. You can see specifically, I have not mentioned the name over here, by the way. That means the customer name. There is a reason behind it. I'll tell you why in a moment. but this is how it looks. This is the table. So maybe somebody may be having an account number of A002, customer ID of C002. His balance may be 20,000. Okay, similarly A003, customer ID maybe something like C005. I'm putting deliberately C05 so that you don't think that these account numbers and customer IDs are following a particular sequence. They are independent numbers, by the way. Just hypothetically I'm writing it this way so that you get a feel, and deliberately I'm writing C005 so that you understand that there's no direct numerical calculative relation between account number and customer ID. They are independent numbers. So maybe this guy has 50,000 balance. So the moment you somebody, let's say somebody who's having a customer ID of C005 does a fetch from his mobile device for the balance, he is actually connecting to this table, fetching this record, not okay, so I mentioned the wrong thing, not C005 but account number A003. Okay, because you'll fetch the balance basis an account number, because a single customer ID can have multiple account numbers. By the way, this is a banking example which I have taken. So A003 account number, what is the balance? If this customer checks, then he will get this number in response. Why is getting this number in response? Because this table is maintained somewhere in a database. Okay, so that is the whole idea of a database. It's nothing but a place where your data is stored, maybe in a structured format. Okay, there is a specific reason why I am calling this as structured, because the example which I gave you is of RDBMS. Okay, it is called as relational database management system. Okay, now I'll explain in a bit why is it called as relational database management system, and I also explain you the concept of primary key and foreign key. But before that, let me just go to another page. Okay, so again a quick recap. So whenever a customer accesses anything from his mobile app, he is actually interacting with some kind of a database at the back end. The example which I took was simple get balance. So we know now how this mobile app connects over the internet, connects to some DNS, how the URL is accessed and how it enters our data center. Then there is a web layer on which it hits, then there is an app layer, then there is a database layer. So when I talk about layers, there are actual instances or servers over here. Okay, and you have your connections going to this server. This database is something which we just saw. They are nothing but tables, right? Inside these databases are tables, and there are a few concepts which you should know, because there is a structure involved. So for example, if I talk about any database, there is something called as schema and tables. Okay, so when I say schema and tables, is that you can imagine that if you imagine that you have an office, banking office, right, which has many departments such as retail or corporate. Then in every department you have files, right? So how you can imagine schema, or how you can imagine both schema and tables, that at the top layer it always starts with a database. That means you will have a database by the name, let's say bank DB. Okay, within this database you will have schemas, right? So these schemas will be what I mentioned over here, such as your retail. Okay, same way there will be corporate. So if you see in retail, there may be customers accounts. In corporate, there may be customers accounts. So you can imagine that there is a big database. You have one name of the database, bank DB. Then there are schemas within it. The schemas can be like departments which are there, and within those departments you may have tables. Okay, so this is again a schema. Then you have tables within that schema. So this is how a normal IT database is structured, and almost all databases follow the same structure. Okay, I'm specifically talking about RDBMS. The NoSQL style of databases follow a different architecture, but we will not focus on that as of now because we want to keep it short and something which can be comprehended fast, right? Okay, so this is the structure of the database. Now when I mentioned app to DB, one important point is that whenever you are connecting from an app to database, there is something called as connection string. Connection string is that if you talk about Java systems or Java applications, it will always be something like JDBC colon, let's say if it's an Oracle database, Oracle colon, then maybe the driver name, then maybe at the rate slash slash your IP address, then port number, right? Then maybe the DB name, which is in case in our example is bank DB, right? This is a connection string which you have to enter. That means this app connects to the DB using some kind of a connection string which you have to remember. Once you connect to this database from the app, then whatever queries you are entering, okay, in those queries you mention the schema name or the this table name. So in the queries your schema name and table names will come. Okay, this is the basic understanding of a database. I hope it is clear till now. Okay, now we'll move on to the concept of your primary key and foreign key. Okay, so again going to the concept of tables, right? In databases, the data is actually stored in tables. So one question which can come to anyone's mind is that if it is only tables, then why not use Excel or Microsoft Excel? Okay, so those softwares are actually meant to be used by end users. Those are not scalable. For example, Excel particular table or let's say a spreadsheet or a table inside it is has a limitation of I think 10 lakh rows. It cannot scale beyond that. So if you want to have millions and billions of records or line items in a table, you need a database and you need that kind of speed and robustness where you can actually fetch data quickly and insert data quickly. For that you need a database, and here what we are looking at is something called as RDBMS, Relational Database Management System. So if you focus on the word relational, this is something important where the concept of primary key and foreign key comes into picture. So quickly, let me just check one thing. Sorry, it is not the correct one. Okay, so primary key and foreign key. So if I take again a banking example, let's say there is a customer table where you have customer ID, okay, as a column, then you have name, then maybe you have mobile number, then you have city, right? And if you have so customer ID in this case will become the primary key. Primary key is nothing but a unique ID for that particular table. So for every customer there will be an ID assigned to the customer which they will use. which will be used for identifying that customer in a unique manner. So for example, you may have, oh sorry, I'm writing the wrong thing over here. You may have a customer ID of C001, and his name can be Ramesh, mobile number can be 9111 city can be Mumbai, then customer ID of C002, then you may have someone like, let's say, Salim, number may be 922, okay, city will be Pune. So this will become one table, okay, and here I mentioned that this is the primary key, okay. Now you may have another table in your this, okay, in your database. Let's say that table is your accounts table, right, which I think I had created some time back, where I deliberately did not put the name, right. So here is your account number, your account ID will be one of the columns, then I think I had put customer ID. You can view that this customer ID is actually coming from here, okay, the same customer ID I have mentioned it over here, and you may have a balance, let's say, okay. Now you can see that I may have an account ID of A001 and customer ID of C001. This portion, write the balance, okay, this C001 is actually coming from here. That means if I want to query this database using a account number, okay, A001, and if I still want to know the mobile number and the city, I don't need to add the mobile number and city over here. I can actually reference using this customer ID over here, okay, and then using the customer ID I can get the details such as mobile number and city from this table. This concept is called as a relational database, okay, and the process of splitting these two databases is called as normalization. I'll explain you why it is called as normalization. So there is one way by which actually you can add this mobile number here itself, okay, whatever, and city over here, okay. Now maybe we have one more column over here, account type. Let's say this is savings, and there is another current account 002, customer ID is same, and maybe balance is 20,000. Again I have to write the number over here, enter the number over here, and city over here. Now imagine that I have to actually maintain these numbers over here properly. What if these change? Let's say the mobile number of the customer has changed, or he has changed the city. Now if I am not using the concept of normalization or relational database where keeping the data separate in some table, what is going to happen is that individually I have to change it over here, here. Imagine if this is a transaction table where there are millions of transactions happening, and if you want to fetch the mobile number for those transactions also, if there is a change, then I need to come here and update those millions of records in a transaction table, right? Maybe transaction ID, then maybe account number, maybe customer ID. If this was a transaction table with millions of records and all of a sudden the mobile number changed and I'm entering the mobile number here in a denormalized format in the same table, then I have to update the mobile number over here for millions of records. Same way, if there is an account table where I gave you an example, there are multiple account types, I have to make a change over here. But to avoid this scenario, we follow the concept of relational database, where in this master table itself it will change, okay, and this change will be automatically be reflected everywhere because they are not actually storing the mobile number, right? They are actually just referencing that mobile number using the customer ID and then getting the other fields, mobile number or city, right? So that you don't need to make a change in millions of tables. There is a relation which you can maintain using a foreign key. Sorry, I didn't mention the foreign keyword. So this is the foreign key, customer ID, and this is the primary key for this table, okay. And if you want to use this parameter or this account ID and then get the mobile number, you can actually use the foreign key, and using the foreign key connect to this table and then reference the value and get the value from here. So this is the concept of primary key, foreign key, which I wanted you guys to understand. So what we understood is that databases are not something very complex stuff. It is just imagine that it's just like a table where you have columns and rows, and there are many databases in the market, Oracle, MS SQL, you have MongoDBs, Cassandras, PostgreSQL. What I explained to you today is only RDBMS, relational databases like Oracle and MS SQL, okay, where you have a relation between multiple tables, okay. The process is called as normalization, and I explained you why it happens, and this is how your data is fetched and data is served to the end customers. I hope this video was informative, and if you liked it, then uh, please put a like and do subscribe. Thank you. Thanks a lot for your time. Thank you. Thanks for watching.